Okay, those of you working on 3.10, Marvin's motorcycle can accelerate at a rate of 4 meters per second squared when he starts from a stop. He accelerates for 8 seconds. Calculate his final speed, which is velocity final. So use a normal problem solving template to solve that. What are you looking for? What did they give you? What formula should you use? And then come over here and solve. Okay. In the problem, circle the given information. I'm going to take this second squared and write it over here so it reads 4 meters per second squared and circle that. That's the acceleration. So this is my A value. When he starts from a stop, that's given information. He accelerates for 8 seconds, and again I'm going to write in a little s over there. That's another given value. Alright, so that's kind of the expectation for how to get that started. What I want to emphasize with you though is what's going on down here, because you're going to need to use a new formula. Let's read letter B. Using this information, generate a table of position time data for the 8-second period. Calculating delta x every second. Use the table below. Alright, so we know he's traveling for 8 seconds. Let's go ahead and write that out. 0, 1, 2, 3, 4, 5, 6, 7, 8. And then it says to get his position, you actually have to calculate delta x. So I'm going to write delta x over here every single second. Okay. So for time equals 0, delta x equals velocity initial times time. And I should actually write this in. Instead of t, I'm going to actually write in times time, which is 0, plus 1/2, which is 0.5, times his acceleration, which was 4 meters per second squared, times time squared, 0 squared. Okay? Well, right away, I forgot to write the velocity initial, which happened to be also 0. So I've got 0 times 0, that goes to 0, plus a number times another number times 0 squared again. So this whole thing goes to 0. So his position at time equals 0 was 0. Okay, let's do the next one. For 1 second, delta x equals velocity initial, which again, his velocity initial was, he started from a stop, 0, times time, which is 1 second, plus a half, which is 0.5, times his acceleration again, times time squared. Well, here's the time value, 1 squared. Okay, so we've got 0 plus, well, 0 times 1 is 0, this goes to 0 again, plus, and then go ahead and multiply this out. Okay, and that becomes your position. So we've got 1/2 times 4 times 1 squared. So 1 squared is 1. So we've got a half times 4, which is 2. Okay. Alright, so that's the expectation for this entire data table. Okay. Then you come over here and generate an xt graph, position time graph, and this object is accelerating, so you should start to think what shape should you expect for that xt graph. Draw the motion diagram. And let's take a look at the back here. Alright, and then as we move here onto the back, we're moving into a new scenario for questions 2 and 3. And then down here, we're generating another position time data table and then another position time graph in a similar manner to what we did back there. Okay, so good luck on this. I think you guys will do a fine job. And just bear in mind those are the two formulae that you'll need for this.